Right, so good afternoon, everyone. Welcome back to our water seminar, and I hope you all had a great time in Hydrology Day last week. Yeah, so today it's our honor to have Karen here to give a talk about a topic for the Colorado Water Center overview and the South Platte Salinity Research Corporation. And Karen right now is a director of Colorado Water Center at CSU. And she leads the center's efforts in outreach, education, and research to address the water challenges in Colorado and beyond. And before she joined the CSU, she worked with the University of Florida Water Institute to address the water quantity and water quality issues through the collaborative research. So I believe she will give an interesting and wonderful talk today. So please join me. Welcome, Karen.
Thanks for the opportunity to be here. How many graduate students, undergrad students? Is this all one or the other? Grad students, all grad students. Any undergrads? No. Okay. Faculty. Okay, good to know. And I think there's a few folks online. Well, again, thanks for the opportunity. I'm going to give just a brief overview of the work that we do at the Colorado Water Center at CSU, and then talk about a specific project that we're working with civil and environmental engineering on to assess salinity issues and solutions in the South Platte River Basin in Colorado. So I am the director of the Colorado Water Center. Just a little bit more about me. I have an interesting pathway. I think a lot of people who work in water, maybe outside of engineering, have more diverse pathways. You all tend to know like what you want to do and where you're going. Other people who end up in water, I think, is kind of like, woo. So I started out, grew up in Illinois on a farm, went and did my undergrad degree at McGill University, was a biology undergraduate, went to the Peace Corps, did Peace Corps Paraguay, and was focused in agriculture extension and kind of small agricultural production in rural places in Paraguay. Came back to the US. I started working for a nonprofit organization called the Sonoran Institute and worked in ecological conservation of the Colorado River Delta in Mexico. So worked primarily on issues of there not being any water in the Delta in Mexico. So binational water management, trying to get water allocated to Mexico for environmental purposes, and then doing the ecological restoration piece, primarily with riparian habitat, some estuarine habitat too. So worked there for about 10 years and was the associate director of the Colorado River Delta program. And then dramatic shift, my husband and I moved to Florida. He's an academic, and so you kind of move around when you're in academia. So we ended up at the University of Florida. I started working for the Water Institute there, and in the introduction mentioned I was working kind of in these collaborative stakeholder and academic teams, really trying to figure out how we best address stakeholder needs with the research and education that we have going on at universities. So that's largely what I'm going to talk about today. And that's why I'm here at the Colorado Water Center, is to really bring needs in Colorado that our communities are facing, bring those to CSU and to drive research in our education and outreach efforts. Okay. So I'll do a little bit on the Water Center, talk about South Platte salinity, ongoing research, and what's happening next. Colorado Water Center. How many have heard of the Water Center before? Oh, wow. That's amazing. I don't think I've ever had that happen before. So hopefully, yeah, people like Neil Gregg are sharing the word of the Colorado Water Center. So we are, again, we're a statewide institution. We're housed under the Office of Engagement and Extension, which is a little different. We used to be housed under the provost and kind of the research side of things. We do kind of all of it. And so depending on administration, maybe will be more research or maybe more kind of engagement. But we are housed under the Office of Engagement and Extension. We're the designated Water Resources Research Institute for the state of Colorado. There's 54 of these in the US and US territories. So we're part of this broad network that was established as part of the Water Resources Research Act. Won't go into all of that, but basically our mission, we're working with stakeholders, we're working with other research institutions, and again, kind of bringing the research and education to our communities and specifically water users in Colorado. We have an engagement first mission at the Colorado Water Center. So I won't harbor on this too much, but listening to the needs of communities and stakeholders across the state on our water issues, convening folks together that have different perspectives, different viewpoints, and hoping to, again, kind of drive research and then address some of those issues, connecting people to resources, contacts, expertise, information, and then including diverse perspectives. So water is one of those really fun topics where everyone has a different perspective and a different viewpoint. And a lot of times all of those viewpoints are valid. And so we tend to think of water. Has anyone ever heard of the term wicked problem? Wicked problems are those that cannot be solved with like a one, like here's your bullet solution. And I think, we come into water, sometimes there are technological solutions to certain issues, engineering solutions. A lot of times we need a bunch of different things. And so we're bringing together the engineering, we're bringing together community leaders and, stakeholders and other interests to really drive solutions forward. So our primary focus areas for the Water Center are agricultural water management, water quality and access, and water education and workforce development. These are the primary areas where we have staff working on at all times. We also do a lot of other things, but these are kind of our driver areas. So in the ag water management space, we're really researching and promoting practices that either improve irrigation efficiency, or we're looking at, low water use alternative cropping systems, systems that are going to lead to water conservation or efficiencies in agriculture. We have water resources specialists across the state. Perry Cabot on the Western Slope is doing a lot of research kind of in the AI and irrigation precision space, drones, and he might, I don't know if any of you are familiar with his work, but he's an engineer doing some really cool work, does some 3D printing of different things too. So he's a fun guy to get to know. If you're ever short on research ideas, connect with Perry and you will have too many. And again, we're kind of doing research, extension, education, and all of these things. In the water quality and access space, one of that focus is the South Platte Salinity, which I'll talk extensively about, but we're also working on other water quality issues across the state, kind of driven again by needs of stakeholders. So one of those issues is mobile home park water quality issues. Jessica Thrasher is working in this space and really convening community members, state agencies, city leaders to understand the issue and then work towards both short and long-term solutions. For some reason, it is extremely complicated, and it's amazing. Again, one of these wicked problems where it's not just, this is an easy solution that we can fix it quickly. So, and then in the water education workforce development space, I will spend some time here because hopefully some of the information I present will be of interest to you all. So I do teach a graduate seminar every fall. It rotates topics. And so typically the course focuses on a water issue and it covers all different aspects of that issue. It might focus on a region. It might focus on a topic. Last fall, we did water conflict and collaboration. And so we go through kind of a range and overview of different conflicts and collaborations. This fall, we're going to focus on the Colorado River Basin because it's timely and there's a lot going on in that space. And there's a lot of interest and a lot of need for research and discussion in that space. So if that interests you, it's a 1-credit course. It's open to anyone who wants to attend. You can sign up for that credit, or you can just drop in if there's a particular class that is of interest. It's also available on Zoom, so you can just Zoom in and drop in. We also have an undergraduate course and an online grad course, Water Sustainability in the Western U.S. That's taught by John Tracy. That's a spring semester class. And then that undergrad is the core course for our Sustainable Water Interdisciplinary Minor, or SWIM. And we partner with CSU's School of Global Environmental Sustainability on that minor, and it's kind of a pick and choose your own adventure minor where because water is so interdisciplinary, you can go a lot of different directions with it. Colorado Water Fellows. This is a very exciting program. Has anyone heard of this before? Okay, a few of you, great. So this is a year-long program. It's open to undergrad and grad students. Any student interested in water, you can be from any discipline, gives you a nice stipend, gives you opportunities to not just attend conferences, but have a meaningful role in those conferences, also travel support. I guess, crux of the program is you're in this cohort of water fellows. You meet monthly, you learn about different water topics, and in that process, you're connected with water professionals from different sectors. You're connected to internships and jobs, and we just expanded the program to now 10 different universities and colleges across the state. So the cohort has gone from just being CSU to now it's like statewide. This year we had 43 water fellows, I believe. So this is a really exciting program. Great to really get dialed into that professional space. It's a nice bridge into that professional space. In addition, we're doing some other things in water workforce development. So we hold a water workforce summit every 2 years where we get together professionals, students, educators to kind of hash out issues in water workforce. Like students might say, I developed all these skills in my coursework, but the people are hiring at this level that doesn't include any of those skills. There's a mismatch. And so we talk about that. We talk about ways to solve some of those gaps. And then we have an annual career fair, which is held annually in February. So we'll have another one coming up February 2027. We also are developing an online hub for water education and workforce resources. That's going to be out in June. So this is like, there's 20 different job boards where you can find water-related careers. This is going to have them all in one place, so you don't have to Google and search them and try and find them. It's also going to compile information regionally, et cetera. So that's an exciting project. Again, hoping to help students and professionals just dial into the information that's out there in an easier way. And then we have scholarships, internships, and student positions that are open on a regular basis. So if you like the Water Center, we can talk more. And then lastly, we have funding for water research. And unfortunately, all of our RFPs are closed at this point. So we typically release these RFPs in January. And we have an internal competitive grant program. We administer funding through the USGS as part of being our National Institute of Water Resources. And through the USGS 104B program, we fund it's currently 7 graduate student research projects of $10,000 each. And those are, very successful. We get wonderful proposals from all different groups. That is open to any college or university in Colorado. And then we also administer a Colorado Water Conservation Board research seed grant all around the same time. So the deadline was March to submit. We're evaluating those proposals now. And then we also do a lot of work just out and about in the state. We have a professional development class for community leaders called Water Literate Leaders of Northern Colorado. We partner with counties to do water education series. We have a lecture series that is an endowment, Norm Evans lecture series, and then we partner frequently to host different water related events. So again, I don't think I put our newsletter sign up on here, but if you go to our website, you can sign up and get connected to all of the different events. And I'll just make a plug, you know, we're applying for funding for research. Partnering with the Colorado Water Center is a good way to incorporate stakeholder needs and get those broader impacts that people want in your research proposals, and really do successful co-development of research. And so, you know, a lot of times research in academia can be perceived as kind of top down and ivory tower. This is a way to have it be more driven from people, communities, and partner with us so that, you know, you personally don't have to be an expert in stakeholder engagement, and we can help facilitate that process. Okay, any questions about all of that so far?
How much have we got in the 104 program now? It comes to the state.
So the funding cycle got a little wonky because they were delayed in their budget approval process. For this round of funding that went out late, we had 146,000 or so that it goes to each institute, and then half of that goes to the grad student research awards. We managed somehow to get a budget increase for the next year. So it's going to be around $200,000. So that means $100,000 will go towards grad student research projects. So even in our challenging budget times, this really goes to show that there is bipartisan support for water research. It's recognized that it's needed, and Congress is willing to fund it. So good news.
Yeah, that's great news. Is the USGS taking a big hit themselves? So
Yeah.
I thought they were.
Yep. And it continues, you know, like I was just on a call earlier today where the USGS budget was zeroed out. The Water Resources Research Act budget was zeroed out. And so Congress puts that back in and funds hopefully to a manageable level. But yeah, USGS has taken some big cuts. Yeah. Okay. Water quiz. How many downstream states receive water from Colorado's rivers?
I missed that one last time. I'm not going to try.
8. 10.
$18
Wow.
in Mexico. So, you know, if you look, and this map doesn't show all of it. I might have a map somewhere in here, but if you think about it, water coming from the Rockies, going all of the Colorado River Basin states, Mexico, but then also into the South Platte and the Platte, and then into the Mississippi. So that's covering a lot of ground there, which is pretty amazing. So we're going to switch gears now. We're going to talk about salinity in the South Platte River Basin, and what I think is a wonderful example of collaboration at CSU, and kind of that co-development of research that I was talking about. So South Platte River Basin, this is the basin where we are all at in Colorado. So it's a very significant river basin, less famous than the Colorado River Basin, but very important for Colorado specifically. Covers all of our major, except for Colorado Springs, all of the highly populated areas on the Front Range. Goes a little bit up into Wyoming and then Nebraska down into the Platte. This map is fun. I like it because it shows you the forested headwaters up in our mountains. It shows you our urban areas. And then all of this yellow is agricultural land. And this map shows the green is irrigated agricultural land. And so you can see how the ag land, irrigated ag, really follows the South Platte, like to a T. So very important for irrigated agriculture. And this might be a little outdated. You know, we continue to lose irrigated agricultural lands on a daily basis, but still very significant for irrigated ag land. The highest producing basin in Colorado in terms of the value of products sold. And so very important agriculturally, also very important for our urban areas, huge generator economic growth, and some of the highest growth areas for population. So all, of course, the Denver metro area, but then Weld and Larimer County are growing very rapidly as well. 70% of Colorado's population is within this basin. It has a projected growth rate of nearly twice the national average. And what that means is there's just growing competition, right? When we have increasing populations, we have ag use, we have years like this year where our water supply is extremely limited. And I love this diagram because it shows you the dark blue is like a typical wet year, the light blue is a typical dry year for our river systems. And it represents a snake diagram representing the amount of flow going out of the state for each river. So as you can see, the majority of our water is flowing to the western portion of the state. The majority of our population lives in the eastern portion of the state. And so there's a mismatch of the water and the people. In addition, we have a lot of irrigated agriculture in the eastern portion of the state. So our South Platte River, you know, still quite mighty, very important. Nothing compared to the amount of water coming into the Colorado River. So the mean annual flow is 1.4 million acre feet. That's just the flow within the basin itself. And this is a fun summary of water resources in the South Platte. So we've got the native flows, which just means the water coming from the basin itself. We also have trans-basin water diversion. So we get water from the Colorado River, about 400,000 acre feet per year. And then we also have groundwater aquifers. The demand, so the amount of water that we're diverting every year is around 4 million acre feet. If you add up those numbers, they don't add up. Why? Why is that? It's because we're using and reusing water over and over again in the system. So let's say, you know, City of Fort Collins using some water, they put it down the line in their wastewater treatment, they're releasing it back into the South Platte. Farmers irrigating crops, some of that water goes back into the groundwater system. Down the line, they're using that water, and it just gets used about 7 times before leaving the state for the South Platte River Basin. So those return flows are critical in this whole economic and very complex socio-ecological system. But that has ramifications. And one of those ramifications is that things can accumulate in the water as we use and reuse it over and over. And one of those things is salinity. So a little bit of primer on salinity. I don't know how much background you all have in this. Maybe I don't need to go over this. Yes, no, maybe so. All natural water and soil contains salts, chemical compound. We've got positively charged ions, negatively charged ions coming together, no net charge. There's some common examples there: table salt, gypsum, lime. What's interesting about salts is that different salts have different implications for water, soil, and crop health. So you could have a really high concentration of a certain compound, but it doesn't affect the crops. You have a moderate amount of another compound, and it's going to cause all of your, beans to die or something. Different sources of salinity in the South Platte River Basin. So there's lots of different things here. Geology, just the weathering of rock and sediments. Different human activities. Road de-icing is a big one. Urban runoff, water and wastewater treatment, oil and gas activity, and then we live in a climate where evaporation is greater than precipitation, and so we're tending to get the accumulation of salts and other things in our soils. Also in some areas, especially in the lower South Platte, close to the Nebraska line, we have quite a high groundwater table, which is caused by those return flows. And so there's so much water in the system that it's pushing salts up to the surface in that high water table, and that's preventing leaching. So it's an interesting conundrum there. And then again, as I mentioned, just the reuse over and over, we're getting accumulation of salt. Why do we care? What are the impacts? It's very difficult and expensive to treat for municipalities. And so the technology right now is reverse osmosis. When you do reverse osmosis, you get a brine stream. We are not California, and we cannot put that brine stream into the ocean. Therefore, we have to typically dig deep wells and inject that brine stream into the wells, which is very, very, very expensive. And this is a barrier, not just for, I think, salinity treatment, but for water reuse in general in Colorado is how are we treating water and it getting to a high quality without creating these brine streams and having to do deep well injection. Salinity also damages infrastructure over time, can interact with other pollutants, and can concentrate and mobilize those pollutants. It can be harmful to aquatic life and cause reduction in crop yield and lead to plant fatality if it's high enough. So this is a table of crop salt tolerance by species. I'll just highlight some of the ones that are more actively produced in the South Platte River Basin, or at least were. So dry beans and onions are in the sensitive range. This is in the decisiemens per meter. And anecdotally, we have heard that, a lot of producers in the South Platte Basin can no longer produce dry beans because of it's just too salty now. So already starting to affect production. Alfalfa, corn are in the moderately sensitive range, and then soybean, not a lot of soy produced, but some in the moderately tolerant, and then going all the way up to barley is tolerant. So with all of this happening, there's increasing salinity in the basin, and folks from municipalities to agricultural producers in the South Platte started to come together and say, hey, we need to have some sort of coordinated effort on this, and we need to understand what the sources are, what the concentrations are, what are the impacts. So in about 2020, a group got together. They got a grant to fund some initial research. And this stakeholder group that came together has continued to meet and work together over the past now 6 years. And it was originally facilitated by Colorado Water Center staff with support from Northern Colorado Water Conservancy District. And I'll talk a little bit just about that group. So it's really focused on bringing together folks to understand the concerns and needs, and then use that to drive research. So using the needs to drive the research, and then eventually develop collaborative solutions. So I'm really on kind of the stakeholder engagement side. And I wanted to ask a question. So these are all of the different types of stakeholders that we work with. How many folks have really heard about stakeholder engagement before? Is this something that's in your vocabulary? A little bit? Why might stakeholder engagement be good or important to a project?
They'll buy in later if they participate early.
That's right. Yeah, so you know, kind of the, when we think about water specific projects, I can give you many. Let's think about the Northern Integrated Supply Project, which is a big infrastructure project that is in development by Northern Water. That's happening here in Northern Colorado, would potentially supply you with future water if you stay in this region. Proposed 2 different reservoirs, would move 287, actually move the road to a different, it's a huge project, very expensive. These are very complicated. They involve so many different stakeholders. When you bring folks in at the beginning, you get the buy-in, you hear concerns, you know, coming from environmental groups, you hear concerns coming from municipalities. Maybe it starts you thinking about, how could I potentially do this project slightly different so that I'm able to meet those multiple needs? If you don't take that approach, you can go your own way and say, like, this is the best engineering solution that we have. And like, it's right technically, therefore, like, we're going to do it. But if you don't have that buy-in from a lot of your stakeholders who are going to be impacted, you might get it shut down and it might not go through, or it might take 20 years to get through a process, a permitting process. You might get sued, which, you know, you can do stakeholder engagement and you might get sued anyway, but at least you're going to have broader support, and hopefully you might actually have a better outcome as well, that, you know, you can meet your own need with a project, or you can maybe do a few different tweaks that's hopefully not too expensive and meet lots of different needs, and you're going to have bigger, broader support. So just want to make a little pitch for stakeholder engagement. And, you know, you can call that a bunch of different things, but it's really, you know, trying to integrate into your project from the very start the people who are going to be impacted or who might have a say in that project. So maybe you recognize some of the folks in this picture. We went through a long process of just like, you know, what are we doing with this group? What are the concerns? What are the issues? Lots of flip charts, lots of sticky notes, and got to a list of concerns and needs. I'm not going to go into all of them, but you can see there's kind of various, you know, policy, kind of the physical, economic, socio-cultural impacts, and then a lot of the needs were actually around the science. And that's where we started, was like, we really need to just understand the baseline, what's going on, what are the sources, to develop solutions. And very complicated basin. It's heavily managed, and so you have inputs and outputs, and, you know, this ditch and that ditch, and trying to model the system itself is very hard. The river, when you get down to the further reaches, it's braided, it's wide. They pull out all of the water at different points to do irrigation, and so if you're trying to monitor salinity, or you're monitoring flows, like, you really have to understand the management to know what you're seeing in the data, because you're gonna be like, oh, there's zero water in the river today. So it's very complicated. It makes, you know, understanding the problem difficult and tricky. So some of the questions that came out of the needs and concern. So again, this was a process with stakeholders and researchers together. Primary folks involved from CSU have been Dr. Tim Gates, Alan Andelis, Jose Chavez, Mazak Arabi, so engineers mostly, and then Ryan Bailey has been now involved in modeling efforts. So I'll talk a little bit about their research. But these are the questions that we came up with as a group. So again, kind of the focus on the characterization of the problem. What's happening? What are the trends? What's happening over time? And then very importantly, how are different land and water management practices influencing this problem? And so we know if you have a field that is flood irrigated, you're able to flush out the salts fairly easily with that flood irrigation. If you switch to sprinkler irrigation or pivot irrigation, your ability to flush the salts from the system becomes very limited. And, to be determined, I don't know if we have final research on this yet, but if pivot systems are causing increased salinity accumulation in soil because we can't flush it out as you would with flood irrigation. And so, good for irrigation efficiency, maybe not good for your water and soil salinity management. So looking at the impacts of agricultural irrigation practices, in addition, municipal and industrial water use and treatment. And then what are the impacts? This is still kind of anecdotal. So we hear, yields are going down, or we hear we've switched crops, but there hasn't been, to my knowledge, data collected on actual yield impacts from salt in these areas. And then, who is it a problem for? Where? If it's not, when? Because it will be a when. Salinity is not going to be going down in the system anytime soon. This is increasing salinization is a problem globally, especially in agricultural systems. It's a global issue that is, we're not going to see trends of declining salinity in the South Platte River Basin. So it's not if, it's when. And then what are the implications for species, groundwater, agriculture, municipalities, and other states? Because this does flow into Nebraska. And then finally is how do we then start to manage and mitigate for salinity? And the hope is too, by having this large kind of collaborative group, it's not just going to be up to one entity or organization to try and tackle this problem. Because everyone is affected, because everyone is contributing in some way to the problem, we need to have a collaborative, strategy to address it, which will hopefully include, funding from lots of different sources to address it. So I'm going to show a little bit of the research results. And these are, this initial map is from 2020, the first study that was done by a consulting group. The general trend, so upstream of Denver, we've got about 600 milligrams per liter. This is total dissolved solids. And then some of the tributaries are high. We're still kind of looking into the why of that. And then getting close to the Nebraska state line, we're getting all the way up to 1,300 milligrams per liter, which is a pretty significant increase. Again, it's the accumulation as we move down that reuse system. This is another study that was done by the same consultant in 2023, this time showing kind of the differences between surface water and groundwater in the spring and summer. But in general, the trend is about the same. We've got, 600 milligrams per liter. This graph is like the map that I showed, only it's on a graph. And so this is upstream in Denver. That's the Nebraska state line. So as you get close to the Nebraska state line, we're getting into that 1,300 milligram per liter range. So this is some of the previous work done. We just had, this report was produced at the end of last year by the Colorado Geologic Survey, looking at contributions from rocks. And so what we're finding, Pierre Shale, which is clay, clay rock formation. There's a lot of it in Colorado. There's a lot of it in northern Colorado. That's our biggest contributor. So it has the highest maximum concentration. TDS, primarily sulfate is the big one. So I'm trying to see if I have a mouse or a clicker, but sulfate and then sodium to some extent is fairly high as well. If we're looking at the median concentration, again, Pierre Shale rises to the top, but there's some few other formations that have higher median concentrations. So we know that Pierre Shale is a big contributor. I've heard of efforts in like the lower Arkansas River Basin, which is very similar to the South Platte in a lot of ways, where they have these augmentation ponds where water essentially sits in these ponds for the purpose of infiltrating into groundwater. And there's an effort to ensure that those ponds are not placed in areas where they know there's Pierre shale formation, because they know it's just leaching this salinity and some other bad stuff into the water. And so, that could be a future effort. There's a lot of augmentation ponds in the South Platte as well. So this is work done by Tim Gates and Jose Chavez. So they are, in addition to collecting some of that surface water and groundwater salinity, just that primary data, they're also mapping salinity, soil salinity in some agricultural fields. And hopefully we will be able to tie that to production yields. And so we're already seeing, like in this example here, the alfalfa threshold of salinity. They're planting alfalfa and 100% of the area is over the threshold. And so one would assume then that their production is being affected, right? We just need to quantify it. But this is really, really cool work being done. And I know graduate students have been helping on these efforts. So this is the work of Dr. Ryan Bailey. So he's been doing the modeling, tying together, looking at inputs, outputs of the hydrology, and then tying that into salt and looking at what are the relative contributions of different sources along the way. So he's trying to get funding to develop. Right now he has kind of pieces of the river modeled out. He's trying to get funding to get the whole river reach, the whole river basin modeled. And this will be really helpful because we're able to kind of look at different drivers, again, of that land and water management, change irrigation practices and see how that affects salinity and where. So exciting work being done. And again, I'll just mention too, like, this is ongoing work, and some of the stuff that we're going to be doing in the next year or so is working with stakeholders to develop the scenarios that are going to go into the models. And so what are the scenarios they want to see? Do they want to see like 100% pivot irrigation and Denver population goes to X million, and so we have like more wastewater treatment, whatever the scenarios are, helping the stakeholders to inform that process so that the information we're getting out of the models is useful for them to then make decisions and inform solutions. So next steps, we're still, ongoing research on sources, loads, and trends, modeling land and water use interactions. We're continuing to kind of build out the stakeholder group. We just got funding to develop kind of a roadmap for the group. And so what is it doing? Where are we going? Who are we? And that kind of thing, in future directions. But one of the exciting things we're hoping to do too in the next year or so, with all the research that's being developed, we want to put it all together, have a research synthesis, data dashboard, and platform that can be accessed easily by different stakeholders in the basin to use and inform management solutions. And so big part of what we're going to be working on is just kind of that liaison between research and stakeholders and interpreting results and translating that into action. So we have a website if you want to learn more about that group or some of the research efforts that are ongoing. You can click on that QR, and then that's my email and our website. We have a lot of information on our website. If you heard about a program that you want to find out more about, go to our website or just email me and I'd be happy to connect you. So thanks again for your time. Questions?
I can still have a minute, so.
Yeah. The challenge of, controlling a salinity in the basin is one of those wicked problems, as you mentioned. And I read a paper somewhere, and I think it was a case study in some state. It could have been Idaho or somewhere that they had similar problem, and they were treated like salinity controlled districts or something like that. And they're gonna have some funding flows and all of that. And I was just thinking, here, the people upstream are causing the problem and the people downstream are suffering from the problem. It'd be hard to figure out how to have the credits, but that could be an approach where, I don't know what the form would look like, but some way to incentivize good behavior, so that we can get on top of this. Otherwise, it looks like it's just gonna be more study as we go down the road and not too much improvement.
Yeah, and I do think there are salinity drivers upstream, but I also think, there's a goodly amount of salinity coming into the system from groundwater and irrigated ag. And so, understanding how that fits together, but then, what is the mechanism by which we're able to actually address some of the problems, which usually is through funding. In our funding limited environment, is always a good question. Wicked problem.
Well, Bob Longenbaugh had a solution to that high groundwater table, as I recall, it was to monitor that better and have some pumping plans and lower those groundwater tables and use that water. Use the South Platte Aquifer as a storage vessel. That could have some possibility, but I think the Institute studied that and it came out uncertain with results or something like that. Reagan was involved in that.
Yeah, I know there's been talk of putting in like drainage. So, I come from Illinois and pretty much all the fields have drainage underneath. They've got, now it's tiles, PVC or like plastic tile. It used to be actually like earthenware. But so there's been talk of tiling and putting in drainage systems. I don't know if folks are at that point yet, but because it is expensive, it's expensive to manage. But I think you might see a tipping point of if that is one of the major problems for a producer is this high groundwater table, and it's causing yield declines, like maybe that would be a solution. But can we capture that water and use it for something else, right?
Well, thanks for the talk. I have a question about the ecosystem impact from the salinity, because what you presented, they already did research about the salinity impact to like the agricultural plants. But how about the natural vegetation, like the floodplain vegetation? If the salinity will cause some damage for them, then in the long term, we might be losing the floodplain and there will be a disaster, because we know floodplain is very important for like keeping water and supporting the ecosystem. So I was wondering like if there's any potential or concern like this group will be doing that kind of research in the future.
That is a great question. And it has not been raised with respect to like riparian habitat specifically. And I think, I actually did a lot of that I did research on the impact of a pulse flow release in the Colorado River Delta on native vegetation establishment, where there was very high salinity in the soil, like, crazy high.
Right.
And it is a problem for seedling establishment. For the mature species, it eventually, it can make them die, but they have a higher tolerance than those little, than seed germination or seedling establishment. But that is a really good, I think that's a good point and something to consider, like for our riparian habitat, because there is quite a bit in the South Platte. What are the implications? At what point does that start to affect that? And what is the impact then on, birds and wildlife?
Yeah. And especially for this ecosystem is freshwater ecosystem. So definitely they should be more sensitive to salinity compared to like the river delta system?
Yeah, the estuarine part was a different story. Yeah, I was talking about the river corridor
Oh, okay.
in Mexico, the river corridor in Mexico. Yeah, we have we call the deltas like the whole part in Mexico, but it's actually the river corridor
I
and
see.
then the estuary. I was gonna say too, with respect to impacts on like aquatic
Mhm,
wildlife,
mhm.
people haven't really looked at that specifically either. Again, this is a heavily managed system, and so this is a river that goes completely dry
Mhm.
when they use it for irrigation. And so, like, is salinity impacting fish? Probably, but is like taking all the water out of the river impacting fish? That's probably a bigger,
Exactly.
bigger impact. So,
Okay, and I have another question about the first part. You talked about the engagement with the stakeholders. So I was wondering, like, typically how it happened. Like for us, like we are faculty, we have some idea, and usually it's like we go to approach them and deliver the idea like we have some research question and maybe they can benefit you, or it's the opposite, like they have some concerns. They come to you, the water center, and you deliver the message to us like, okay, these are the group might be able to help you. I don't know what's the direction, or is it either way?
I would say it's both ways. So in some of our RFPs and our requests for proposals, like the research priorities are driven by stakeholder needs. And so, the Colorado Water Conservation Board one, that's all their research needs. And the CSU internal one, that's gathered from our advisory board. It's gathered from like external partners. So that's one way in which that's informing research. And then, yeah, we've had several instances of where we'll be in communication with folks about an issue, stakeholders. And they're like, yeah, do you have anyone who's doing this work? Like I can name 5 right now that we're connecting people with researchers. I think you can do it the other way, but it's often not as successful. So like if you have a research idea and you're like, I need a stakeholder to involve in this research, and you're like, do you have any stakeholders? And then I'm like, yeah, I'll connect you with Denver Water. And they're like, well, this isn't really,
Mhm.
I think it works better when it's driven,
Right, right,
but it's hard to do that. And it takes time
right.
to
right.
build those relationships. But if you keep engaged with the
Mhm.
Colorado Water Center, like that'll happen over
Right.
time. Yeah.
That's why we love to have you
Yeah.
here as a connection.
Other questions? Yeah.
So I come from Minnesota, where our salinity issues are largely self-imposed with road salt, which probably isn't as big of a deal here. But it seems like a more solvable problem, right? I'm wondering are there any like low-hanging fruit? I don't think you talked about like the proportion of the salt that comes from different sources or anything like that, but like, are there any anthropogenic sources that are not ag related, which is very diffuse that we can tackle?
Yeah, we don't have those results yet, so that'll be like coming hopefully this summer. We're going to see some of that work. But I do think there's like the road salt is a somewhat easy. I wouldn't say it's like low hanging fruit because that involves like public education and working with municipalities on providing that messaging and education. And in some cases, like, there's always a safety balance. So like we do need road salt. And how much is too much? How much is like being safe? And so that could be a good one, I think, especially for some of those tributaries. And then there could be, I think where a lot of, and I know people are doing research on this, but like we need different treatment technologies that are going to produce a smaller brine stream, lesser amount. And there's research being done on that, but it's not there yet. So that could really help to reduced salinity that's coming out of like wastewater treatment plants and other sources.
Why is the salinity never gonna be, you said it's always gonna be a problem? Is it because the leaching from those rock formations is so apparent here? And like, on what time scale, like, are they always gonna be leaching? Is it just like this continuous, like,
Yeah.
situation, half-life situation, like?
Yeah, that's a good, I don't know the answer to that geologic question. I would imagine it's gonna be like far beyond our, human lives. Just with the geologic time, but the reason why it's not gonna go down also has to do with like where we're at with climate and increasing temperatures. Like the system is getting water is getting tighter in the system. There's less water. It's more heavily like managed. So there's not a lot of like free flowing water around that's washing out the system and flushing salts. And as temperatures continue to increase, which is a very real trend for Colorado, that's gonna also be a big factor. Good question.
Can you tell us when the drought is gonna end?
We got rain yesterday.
Don't count on it, Neil. Don't count on it. I wish I could tell you, but I'm afraid it's not. I mean, even if we have wonderful amounts of rain, we're dug pretty deep right now. So
Yeah.
Yeah.
I noticed that the Northern District just declared their quota 80%, which is a little higher than average. And that's worrisome in terms of how we're gonna refill what they got over the Western Slope.
that's right.
Yeah.
That's right. Yep. They have they said they have, I think, 170% stored right now. And so they have, some buffer of if they don't fill much, but if we have multiple years of drought, if we have another year like this year, everyone's gonna be in big trouble. And that's the fragility of this system. I mean, but yeah, just one more. This is a record year, like historic record drought, record low snowpack, record temperatures, March, the whole winter. And so it's going to be a rough one. I think we're going to see people going out of ag, where there's going to be big impacts. So just wanted to put that fun note out there as we conclude. But yeah, please follow up with any questions or just connect with the Water Center. Thanks for your time again. Appreciate it.